Hi, we're going to discuss parametric relations, and sometimes you have situations where both x and y of your coordinates are going to depend on another variable that we call a parameter, and that parameter is often denoted as t. Let's take a look. So we have let x be t plus 1 and y be t squared minus 2. So the first thing we want to do is learn how to write pairs for the given value of t, which is actually very easy. To get x, you take this number, substitute it here. So 1 plus 1 gives you 2. So the x coordinate will be 2. And to get the y coordinate, you do 1. You substitute 1 in here. 1 squared minus 2 will give you negative 1. So our point when t is 1, the xy coordinate will be 2, negative 1. So you understand to do that for part B, it's the same thing. You take 3, substitute it into the x expression first, 3 plus 1 is 4, and then substitute 3 in here, 3 squared minus 2 will give you 7. Eliminate the parameter. That sometimes can be a challenging step, but in this case it's not actually a challenging step. So what we want to do is solve one of the equations, whichever one is easier. In this case it's this one for t, and then substitute that into the second equation and see what you're going to get. So when you solve the first equation for t, it's going to be t equals x minus 1, and then you substitute it into the y equation, so it's going to be y equals x minus 1, because that's what t is squared minus 2. It's going to give us y equals x squared minus 2x plus 1 minus 2, which is going to equal x squared minus 2x minus 1. That's our equation. So y equals x squared minus 2x minus 1. Is this a function? Yes, it is, because for every x that you're going to put here, you are only going to get a unique value of y. Right here, y equals x squared minus 2x minus 1. Next example, you got x equals t squared plus 1 and y equals t squared minus 5. We have the same set of questions. Find one point, so we have 1. 1 squared plus 1 will give us 2. And here 1 squared minus 5, that's going to give us negative 4. When x is 3, when t is 3, 3 squared plus 1 will give you 10. 3 squared minus 5 will give you 4. Eliminate the parameter. In this case, they both contain t squared, and what we are going to do is solve each equation for t squared and then put them together. That means that from the first equation, t squared is going to equal x minus 1, and the second equation is going to give us t squared equals y plus 5. And then because t squared by transitive property, these two things are going to equal each other. I'm going to put y first, so y plus 5 equals x minus 1, which gives us y equals x minus 6. That is a linear equation actually, and that is of course a function. Next, we got x equals t squared plus 1, y equals t minus 5. We're going to use these values. T, negative 2. That means x is going to be negative 2 squared plus 1, that is 5. And negative 2 minus 5 is going to be negative 7. When t is 1, substitute it here. 1 squared plus 1 is 2. And then 1 minus 5 is going to give us negative 4. Eliminate the parameter. The equation that is easier to solve for t is the one that has y in it. That is going to be t equals y plus 5. And now we have to take this equation, substitute it into x. So x equals y plus 5 squared plus 1. X equals y squared plus 10y plus 25 plus 1. X equals y squared plus 10y plus 26. This here does not represent y as a function of x, because you're not going to be able to solve, well, there is a way to solve this equation for y, but when you try to do that, let me do that on the side here. Before I expand, we have y plus 5 squared equals x minus 1, which is y plus 5 equals plus or minus square root of x minus 1, and y equals plus or minus, well, actually let me write it as 5 plus or minus square root of x minus 1. So what's going to happen here for any values of x that I can use in this function, you are going to get two different values of y. That's not a function. But by the way, this is enough for you to do elimination of the parameter. This is just to help you understand why this is not a function. Okay, our last example, x equals square root of t, y equals t squared plus 2. Find the pair for 0. So when x is, t is 0, you're going to get 0. When t is 0, y is going to be 2. When t is 4, x is going to be 2. And when t is 4, y is going to be 16 plus 2, 18. To eliminate the parameter here, what you are going to do is you can solve the first equation, the x equation for t, which is going to give you t equals x squared, and substitute it into the second equation, which is y equals x squared plus 2. That gives you y equals x to the 4th plus 2. That is going to be a function, because for every x that you can use, you're going to get a unique value of y. So this is our introduction to parametric relations and parametric equations. Hope this helps.